This is Rosa Gallardo and I will be discussing mercury. I will be giving a brief account of the physical properties of mercury, characteristics of mercury, potential health effects, common control methods, and inward references. Mercury is a natural occurring element and is found in water, air, and soil. Mercury can exist in various forms in nature, organic and inorganic. Inorganic mercury can be further divided into elemental mercury and mercury salts. It is the only liquid metal found at room temperature and pressure. When mercury is frozen, it can turn into a solid at temperatures of -38.87 degrees Celsius. When mercury is boiled, it can turn into a gas at temperatures of 356.73 degrees Celsius. Mercury is an odorless liquid that is silvery white in color. It is the densest liquid known, with values ranging in at 13.534 grams per cubic centimeter at 25 degrees Celsius. Its surface tension is also high at 470 dynes per centimeter at 20 degrees Celsius. Mercury is a good conductor of electricity. Mercury is highly corrosive when found in inorganic mercury salts, for example batteries. It can get into the body via several routes of exposure, including the oral and the dermal routes, and tends to accumulate mostly in the kidneys. Mercury itself is not ignitable, but when combined with other compounds, it's highly ignitable. An example of this is mercury fulminate. It ignites at low temperatures of approximately 170 degrees Celsius. It is also sensitive to friction and impact. Although mercury is stable under normal temperatures and pressures, it is highly incompatible with other materials, making it highly reactive. For example, when combined with oxygens at 350 degrees Celsius, it forms mercury oxide. Once it reaches 400 degrees Celsius, it becomes a hazardous decomposition product. Mercury will only react with concentrated forms of nitric acid and hot sulfuric acid, and reacts slower with diluted versions of the above-mentioned acids. Mercury is reactive with other metals, for instance cadmium, zinc, gold, and silver. The alloys are called amalgams, and they are used to create dental fillings with silver, extract ore with gold, and batteries with zinc and cadmium. Mercury is extremely toxic and must be handled with care. At high levels, mercury can affect the brain, kidney, heart, lungs, and the immune system of people of all ages. The features that determine how severe the health effect on humans will be when they come in contact with mercury include the dose, the chemical form, route of exposure, and length of exposure. The fetus is the most vulnerable to mercury poisoning. This occurs by harming their nervous system. The chemical forms that have the most effect on human health are methylmercury and elemental mercury. Methylmercury is considered to be the most toxic form of mercury. It affects the neurological development of the fetus in the mother's womb. It also affects infants and children. Methylmercury is completely absorbed in the gastrointestinal tract, and the main route of exposure in adults is oral, via the consumption of fish and shellfish. Ingestion can cause permanent damage to the digestive tract, such as perforation. Although elemental mercury is less toxic than methylmercury, it can be found in higher concentration in gold mines, where it is used to extract gold. Elemental mercury causes health effects predominantly when it is inhaled in as a vapor and absorbed in the lungs. Inhalation can cause chemical burns to the respiratory tract. It can also cause metal fume fever, which has symptoms similar to the flu. It causes nervous system effects such as vertigo, muscle coordination, and emotional instability, to name a few. This is a flow diagram of mercury throughout the environment. In the United States, coal-fired power plants are the primary source of emissions of mercury, and it is a major environmental concern. The state environmental agencies have established control methods because of the persistence of mercury in the environment and its toxicity. In previous years, to reduce emissions of mercury from these plants, wet flue gas desulfurization, FGD, and fabric filters were used. Following FGD and fabric filters, other mechanisms such as the use of homogeneous and heterogeneous reactions were introduced. These types of reactions basically worked on the principles of converting elemental mercury into an ionized state, as this form of mercury was easier to capture than in its elemental form. However, these two mechanisms have been found to be less effective when dealing with low-form ranks of subbituminous coals, and therefore were replaced by newer mechanisms of mercury elimination. Most recently, other methods have been introduced, Sorbent injection is one method to control mercury emissions. Here is a schematic of sorbent injection. It consists of powdered activated carbon, PAC, which absorbs mercury at increased levels and faster rates in comparison to the old system of homogeneous and heterogeneous reactions. However, due to the high temperatures that occur in coal-fired power plants, PACs have been found to be less effective as the levels of mercury absorbance decreases in temperatures exceeding 350 degrees Fahrenheit. Due to further research, it has been found that enhanced PAC, silica-based sorbents, can in fact operate at more elevated temperatures, thereby increasing the level of absorbance of mercury and ultimately decreasing mercury emissions into the environment. Here are a list of my references. That is the end of my presentation. Thank you for listening.